Okay, an exercise of a pretty high level. This is the one that we're going to do to understand how to find the composite and the inverse of functions. In other video you can find the inverse of a function, how to find it, and here we're going to explore both the composite and the inverse. And this is the example that we're about to work on. We're going to take two functions. So the first function is fx equals 1 over x squared minus 25, and the other function is going to be g of x equals root of 1 minus x. Okay, and as an exercise we're going to find f composite g. Okay, we're going to use the notation f composite g. This is the exercise we're going to find first, and then we're gonna call it hx, and then we're going to find the inverse of h. Okay, so first the composite, then the inverse. So what is the composite? The composite is to take the new variable. So instead of x we're going to set g of x, so it means that we're going to set root of 1 minus x. This is what we're going to do to find fx, to find f composite g. So fx is the composite. We're going to find the composite. So f composite g of x is 1 over, and instead of x, the g of x, so root of 1 minus x to the second power minus, in black, minus 25. Okay, so let's solve. The root to the second power is gonna give 1 minus x minus 25, and minus 25 plus 1 is negative 24, so minus x minus 24. We can factor here a negative sign, and the composite is the composite is going to be minus 1 over x plus 24. That's the composite. Now remember that to check any function, or before doing anything about the function, you got to check the domain. So how to set the domain? The domain depends on the domain of g and the domain of fx. But first, for the composite, we got to check the domain of g of x. Okay, so we need the domain of g of x. Remember that here the domain is any number for which the argument is greater than or equals than 0. In this case, if I add by x, it will be 1 greater than or equals than x, or x less than or equals than 1. So the domain is just x, such as x less than or equals to 1. Okay, this is the domain of g of x. and how to find the domain of the function. So as x is any number, this x should be any number less than or equal than 1. So if I set any number less than or equal than 1, we're gonna find the domain here, but we cannot include when the domain, when the expression is 0. So for here the expression is 0. When x plus 24 is different than 0, it means that x is different than negative 24. And remember that here it means that we cannot use x negative 24. Also, you gotta take into account that here, according to the domain of fx, if I apply difference of squares, take into account that here for fx is not possible to have x equals 5 and x equals negative 5. So I should include here the condition for fx, that is x is different than negative 5. We don't include 5 because obviously 5 is greater than 1, so it's not needed to write it. Okay, so this is the domain. The domain of the composite is x such as x less than or equal than 1, x different than negative 5, and x different than negative 24. Okay, this is the composite. This is the composite. And that's it. That's how you find the composite of a function. Now, in another video, or in the next video, we're going to determine the inverse of this function. Okay, we're going to see the inverse of this function. So if you're interested, so stay here and wait for the next video that it's about the inverse of this function. So I hope that you understand how to get the composite and how to get the domain of the composite of a function. Have a nice day and see you in the next video. Bye.